Exercise 79 rather, question number 7. So we've got a metal sphere with a mass of 24 kilograms. It says it weighs 24 kilograms, but they mean the mass is 24 kilograms. And that particular material has a density of 8,000 kilograms per cubic meter. That's been melted down and cast into a cone, so with a radius of 8 centimeters, a base radius of 8 centimeters. So the key is that the volume's the same, of course, when you melt it down and cast it. So the idea here is to find the volume of the sphere from the information given, and then once you've got the volume, you can put that into this formula to find that into the formula for the volume of the cylinder to find the perpendicular height. We have to be careful of units, because if we look at the density, that's in cubic meters. The mass is in kilograms and the density is in kilograms per cubic meters, so you're going to end up with a volume in cubic meters, but the radius is in centimeters. So I would suggest that the best thing to do is stick to meters initially, certainly, so the radius would be dividing by 100, 0.08 meters, which you will then put into the formula for the volume of a cylinder to find the perpendicular height. So see if you can have a go at it. I'll work through the solution below. So initially we need to find the volume, and we've got the familiar formula, density is mass over volume. Rearranging that formula for volume, we've got volume equals mass over density. So we need to divide the mass of the cylinder, the sphere rather, by the density of the material to get the volume. So the volume will equal 24 kilograms divided by 8,000 kilograms per cubic meter, and that gives us a volume at 0.003 cubic meters. So now we know the volume, we need the formula for the volume of a cylinder, a cone, and that is 1/3 pi times the radius squared times h, where h is the perpendicular height of the cone. We're after the perpendicular height of the cone, so we have to rearrange this for the height, so that's going to equal the volume divided by 1/3 pi r cubed, pi r squared rather. Actually that's the same as 3v, so the height equals 3v over pi r squared. At this stage here, I might have multiplied, at this point, I might have multiplied both sides by 3 first to get 3v equals pi r squared, then divided by pi r squared. Either way, you'll get the same answer. So that's the final formula to use. Now plug in the figures and you should get the answer in the text.